Perfect. Okay, Vicky, now that you can show us some code, why don't you run us through some runnables, executors, and threads?
I just hear some parts of your talk.
Okay. Can you show us runnables and threads?
Second. Components. So like I just need 1 or 2 minutes and I can show. Okay.
Okay.
You can explain about our submission for Friday before I will start. Yeah.
Yeah.
Can you?
So I think if we finish our code topics for this week and we upload all of our Sandbox code to GitHub, and then I'm pretty sure if we do that by Friday, we'll have 3 code topics done. I think it'd be beneficial to prepare for fluency review for not this Friday, but the next one. So at the end of next week, where we can submit for review of 5 or 6 topics.
So once you're done and upload your code to GitHub,
5 because I don't hear you again. Can you repeat?
so when we upload our code, we have to send Brother Larson a message with the link.
Yeah.
That we
are ready to submit.
Where did I put that? Oh, there it is.
Sorry, guys.
I'm going to upload my code for Java collections right now while we're waiting.
Initializing models. In that, I wish I can show you my sandbox or my project. Drive me crazy. Just want to say something. I was about the Runnable and Executor. I found out that and Runnable, it's the same process, but in different ways. About a little bit about the nasty path error. What usually we have pretty often programmers they are what to say starting. They are using the run method in the public static void main, and it's because we need example in the threads, we need to override the run method. Then we can the second I'm almost done, so I can
Is it still compiling?
No, I'm sharing my screen. Do you see my screen? You see my screen?
Yes, it's all
Yeah.
black right now.
Yeah.
Black
Yeah.
Yes.
code. I will start from threads. You can see the method run.
It's still black.
Black.
Yeah.
Right now, do you see my screen?
So we see your screen, but it's all black.
Right.
I can see that you're using IntelliJ, but the entire screen is black. Are you sharing the window or your screen?
My window and screen. Sorry.
Well, usually there's multiple options when you click on
Yeah.
screen share. You can either share your screen or a particular window.
It's window.
You might want to try just to share your entire screen. That might work better.
Okay.
Oh,
Try.
Yep.
I'm trying to. Okay.
there we
My
go.
screen.
Perfect.
Yep.
That's good. The thread example, what is extends thread? Writing the method run and put here the functionality that we need to perform multi-threaded mode. And we can see the message. Here it is the public void main. Here we can see the creation, the student's creation of the class. In the multi is performed through the start of thread object type. Start method of thread class is invoked. What is the class inheritor? Yeah, you can see. Often, for example, I don't see. For example, the line 22. Okay. Often, instead of calling the sphere, programmers, they can call the run method. It brings the incorrect result. If we will start run, will not see the difference. It will be a single thread, but not multi-thread. Do you understand me?
Yeah.
Yep.
Do you hear me?
Yes.
Yes.
If here we will call the run method, it will since it will be single-threaded mode, but not the multi-threaded mode. Example. Do you hear me, guys?
Yes.
Yes.
Yeah, good. Also, tend to override method because if we will not, it will be an error. I will just read because it's if the implementation of interface requires the signature with the overriding method run. Inheritance does not have a restriction. An error is when in the run method signature automatically changes the status of this method with the override to overloaded. Function will not be displayed any warning or error messages. Of a similar program again will cause unexpected or rather absence thereof, due to the fact that in the absence of the version of the run method is called the implementation of this method, the default, which is located in the thread class. This default implementation does not contain any functionality. Respectively, the flow starts and then stops for it. So for the thread example, it's really important to understand that first, override the method run. On the line 22, we need to call the, because if we will call instead the run method, but yeah, do you hear me?
Yes.
Hello?
Yes, we can hear you.
Do you hear me?
Yeah.
Do you hear me?
Yes, we can hear you, but you skip in and out.
Okay, but did you hear my explanation?
Yes, I did.
Yes.
So, example. Here we have the, which is void, we have the main method. The run method, we put our where we implement the runnable interface, the container object. That we can see the implementation of runnable interface. We're placing an object of this class type thread. Task starts in multiple thread mode is performed through calling the method start of the thread object type. First, there's calling start method of the thread class, and then calling to the run method. And already from this method, calling the run method, implementing the interface runnable. In the runnable example, we have the same error, like nesty path as in thread example. If we will here's 29. Yeah, if we will the run method from the line 20, we'll have the mode, I mean. We'll not see like maybe any changes. If it's if we need the multi-threaded mode, start method. And the last one is Executor example. Here's sorry. What's wrong? Just don't understand this. Here we are using the executor, which has and on the line we are on the line here we need to wait till if and here we are receiving the result. Do you hear me?
Yes.
Yes.
Okay, that's good. Need to work a little bit on executors example because I didn't have the nasty path for it. But if you have questions about that thread example, or maybe you have some comments
So the whole purpose of
data class.
Yeah, so the whole purpose of threads, runnables, and executors is to do multiple things at once.
Again?
The whole purpose of threads, runnables, and executors is to do multiple things at once in a program. Is that correct?
Yes, it is. It is what I want to say.
Cool. Well, that'll be fun researching and learning more about this.
So do you have any comments or suggestions? Since you have done already that, so.
Yeah, don't really have, can't think of nasty paths for that except for the threads. So there's one thing that you could do for the threads for nasty paths. It's called a deadlock. But if you can't find it in Google, I think it's called something else. But maybe you could find it as a deadlock. So you have.
I will work.
So you have like two different threads, but one is waiting for. So the first thread is waiting for an object. For the second thread. So the second thread is also waiting for a log object in the first thread. So since they're waiting for each other, they can't do anything, so they're stuck, and that wouldn't be a good thing.
Together.
Yeah.
I see. Okay. Do you have
All right.
But maybe you want to do it in a different
way
class instead of the same file.
Yeah, because it will be better because he will have the main method to show here. Yeah.
Sounds good. Can you show us some of your Java collections?
Give me a second. Yeah, do you see it?
Yes.
Yeah.
Yes.
Yes.
Do you hear me?
Yes.
So here I have the array list of ordinal numbers. Here I added the 4 values, third and fourth. And we see the valid array list of ordinal numbers. So if we will print, we'll see the first, second, third, and fourth. Another array list of relatives. Added values of grandfather, grandfather, father, and son. Here we are trying to find an existing value, and it will print true because first exists in the array list ordinal numbers. Here, checking if the numbers is empty, and it will print because the ordinal number is empty. Here, second value of number, since it starts from 0. Here, for each loop, and when we are in the each element, here I'm all values from the relatives to the ordinal numbers array list, and then in all values what have relatives. Nesty path. We cannot add the empty value to array list. And we cannot add an existing value what is like bigger than list, and we'll see of index of out of bounds exception, because my array list has 4 values, and after we the relatives to ordinal number array list, it's values in the we cannot remove a null from the array list. So negative value, because a list doesn't have values with a negative integer. Also, we cannot remove all null values, and we'll have the null option. And the last one in the array list example, we cannot add values. We have the exception. It's about array list example. Do you hear me?
Yes.
Yes.
Do you hear me?
Yes.
Yes.
So it's about array list example.
No questions.
No questions.
So can I share my hash map example?
Yes.
Yes.
So here I'm creating the hash map. Key is an integer and the value is a string. Add in the four keys and values to the relatives. Here I'm creating another hash map, what is called the 4 keys and values. Here I'm printing all relatives. Here I'm creating the array list, what's called ordinal number typepath. Here I'm adding the values to the array list. Here I'm adding a new what is and values. Then I'm printing all values and it has the new what is added. Here I'm get the second key and value, and it's supposed to be the grandfather. Removing key and value from the hash map. Checking if the hash map is empty or not, and it false because it's not empty. Here I'm checking if the 3 and true because this the key and has value father. I'm checking if the hash has a value father and true because there is a grandfather value. Placing the first what is father, I mean grandfather to here I each values from the ordinal numbers to the relatives. We will print hash map will have relatives and ordinal numbers together. But sorry, give me just a second. My battery is
Your battery is low.
And read Russian. Sorry. So we cannot add the no key and no value. We cannot add the no value. And we cannot remove key and no value. Also, we cannot remove the key with empty value. We cannot remove the empty value and negative integer key. And also pull not existing hash map keys and values is like doing nothing, and we'll see the no pointer exception. Do you have questions about the hash map example?
No.
Nope.
So can I go to the tree map example?
Yes.
Sure.
Okay. So, and my favorite ordinal numbers, and creating up and adding the key and values. So the array list, we have our happy path. Here I'm adding values to the ordinal number array list, and it's array list. Here I'm printing all of the ordinal numbers, and it's a valid tree map. Here we can get the first key from the ordinal numbers. Here we can get the first try of the ordinal numbers. Here we can get the third value from the ordinal numbers. Here we can check if the ordinal numbers contains second, and it will print true because it exists in the ordinal numbers. Here we can check if our tree map has a key as 4 in the ordinal numbers, and it will print true because like there is 4 as a key. Here I'm replacing the third value, which is third to 6. So if we will print our tree map, we'll see that it will not has will replaced by 6, the nasty path. We cannot add key with the no value. We cannot add the we cannot get a value from our tree map because the 15 does not exist, because we have only 4 keys and values. We cannot add the key and value what is already exists. And we cannot replace the new key and no value. And we cannot all nulls to our tree map. We'll have a no pointer exception. And the last one here, we cannot remove a negative key and also not existing key, because it's we have just 4 key tree map. Do you have questions about tree map?
No.
No.
Greg?
Nope.
Okay, can I start with my tree set?
Okay. We'll finish up with that one.
Yes, it is the last one.
Okay.
So here I'm creating the tree set again with ordinal numbers. I just like it. And adding 4 values to the tree set. Here I'm creating the have called ordinal numbers array list. I'm adding 4 values to the ordinal numbers array list. Here I'm printing all values from the ordinal numbers, and here I'm checking if second exists in the tree set, and it will return true because it exists. And here, yeah, the last value from the tree set, and it returned false because it is the last value in my tree set. Here we can get the first value from the tree set, and it will return first because the first, it is the first value of my ordinal numbers. Here I'm checking if my set ordinal numbers is empty, and it will return false because it's not empty. I'm checking if tree set contains the sevens, and it will return false because my tree set doesn't have any sevens as a value. Nesty path. We cannot add the already existing value because I have already. We cannot remove the value what doesn't exist. I don't have any fixed value in my tree set. I think it's supposed to be copy path. I'm adding the ordinal numbers array list to the ordinal numbers. Here I'm removing the ordinal numbers array list of the ordinal numbers array list from the ordinal numbers. We cannot add the empty string to the tree set. Remove the empty string from the tree set. We cannot add a new value to the tree set, and remove the new value from the tree set. And add all values, all new values. And the last one, we cannot remove all nulls from the. Any questions about the tree set example? Or...
No.
Nope. Looks good.
Much better. So I can stop my screen.
Okay, cool. Oh. All right. Thank you, Vicky, for showing us about threads, runnables, executors, and going over Java code. That's nice.
Thank you.
Yeah.
Sorry for my computer. I feel, I don't know, it's hard to express my feelings.
It's okay. You can say it in
Thank
Russian.
you for
It's
your
fine.
patience. Спасибо большое.
Ah, there we go.
Так
See?
долго ждали. I'm just saying that I'm grateful that waiting for me so long.
No problem.
What are our plans for Friday?
Okay, so Friday, it'll be me presenting on the application control pattern. And then Brian and I will present our threads, executors, and runnables code.
Okay. And that on Friday, I need to leave 10 a.m.
Okay.
At 10 a.m. So like if you need to stay longer, it's okay.
Okay.
And I'm sorry that if I will leave at 10 a.m. and you need still talk about code.
That's not a problem. Let's see, let me just add this for next time here in our little
notes.
Yep. Nine, 28, 16. All right. This will be for, let's see.
Friday.
Let me just share this so we can get it now. There we go. Present on application control pattern. And then Brian and Greg share threads, executors, and runnables. And then that's about it, I think, just these two, right?
Yeah.
Okay. Sounds good.
Sounds good.
Then, yeah, we will meet up at 9 o'clock. I'll make sure I have everything's ready 9 o'clock Friday morning so that we can keep Vicky as long as we can.
Yeah.
All right. Thank you guys for coming. Have a good day, and we'll see you Friday morning.
Thank you.
See you there.
See you
Have a great
Friday.
day.